So the second part then wants us to find the coordinates of the point P in the diagram. So I'll scroll back up here for a second. The P is in here. It's kind of half hidden. I might just get rid of that. Don't really need it anymore. Okay, so the P is there. So you can see that P is a point of intersection between this dotted line and our original graph that we were given. Yeah? So P is there where the dotted line, which we're told is 2y equals 1, intersects with the curve, which we know is sine 2x. Okay? So we're trying to find a point of intersection, which is P. And it's a point of intersection between that line thing, which is 2y equals 1, and the curve, which is f of x equals sine 2x. Okay, so f of x or g of x or h of x or any of those can always be taken out and written as y. So we can rewrite this as y equals sine 2x, and we can also reorganize this so that we have y equals a half. So now if y equals a half and y equals sine 2x, we can say that sine 2x equals a half. And this is one of the cast circle questions. So the first thing you do is you get a reference angle. You do that by doing sine inverse of a half on your calculator. So inverse sine of a half is 30 degrees. So you take your cast circle. Oh, geez, that's horrific. Let's try that again. Okay, it's a little better. And we have our C, our A, our S, and our T. So we have to put this 30 degrees into the two quadrants where sine is positive, because this was a plus a half to start with, it didn't have a minus. So we are looking for the two quadrants where sine is positive. So sine is positive in this quadrant because all of them are positive, and sine is positive in this quadrant because it says S, and that means sine is positive. So we draw our 30 degree angle into both of these quadrants, always making the 30 degree angle, or any angle in these questions, with this line. Okay, so the 30 degrees is always made with the x-axis. So we do a line here and we mark it as 30, and we do one here and we mark it as 30. Okay, so this line represents 0, which means this angle is actually 30 degrees. Whereas this one over here is 30 degrees short of 180, so it's 150 degrees. Okay, so there are two answers, except that this is not x, it's 2x, and we have to take that into account. So we let 2x equal 30, and we let 2x equal 150, and we get x equals 15 and x equals 75. And then you need to go through another rotation, so you add 360 degrees onto this, which brings it to 390, and you divide 390 by 2, so your second answer is 195. And then you add on another 360, so we have 30 plus 360 plus 360 divided by 2, and that gives us 375. So that is rejected, and we do. And then on the far side we do the same thing, so we add on 360 over here. So that's 510, which we divide by 2, which gives us a second answer here of 255. And then we add on another 360, which is 870, and we divide that by 2, which is 435, but because that's outside of 360, we reject that as well. So our possible answers for points of intersection are at 15 degrees, 195 degrees, 75 degrees, or 255 degrees. Okay, so if I scroll back up, it's actually handy that this is coming with me. Okay, so the first time, if I can just get rid of this. Okay, so the first time they intersect here, that's our 15 degrees. The second time they intersect here is this one over here, which you can see just there is 75 degrees. So that second one is 75. The next time they intersect is here, which is going to be our 195 degrees, which means P is going to be 255 degrees. Okay, so the x coordinate of P is 255 degrees, and the y coordinate, because it's on this dotted line, is a half. So the only other thing you would need to do is convert this 255.
I want to watch.
Convert this 255 degrees into radians. So you do that by dividing it by 180 and then multiplying it by pi. So if you divide it by 180 and multiply it by pi, you get, in radians, 17 pi over 12, and your y coordinate is a half. So then they're the coordinates of P.
Mommy, your teacher means today.